The next conic section that we're going to look at is the ellipse, which is really just an oval shape, but in mathematical terms we would call it an ellipse. And for both the ellipse and the hyperbola that we'll look at next, they can be very complicated. We can look at the foci of them. We've got major axis, a minor axis, vertices, co-vertices, a center. There are all sorts of things that you can look at for this. So I'm going to try to keep this as simple as possible. Our whole goal being, first of all, to recognize what the equation of an ellipse looks like, so that later on when you see something like this, you would say, oh, I know that it's an ellipse because of this. Also, that you would just be able to sketch a general ellipse or later a hyperbola, just in case you're needing to use it in a bigger problem. In calculus, this happens sometimes where we just need to know, in general, what does this look like? So for the general equation of the ellipse, and I would go ahead and write this down, we notice a lot of similarities to the circle. We still have that x minus h squared, where h and k are still going to be the center in this case, that y minus k squared. But notice we're not going to have it equal to the radius squared, because in an ellipse we don't have one radius. We actually have two different distances. We've got a vertical distance and a horizontal distance. So that's where this dividing by a squared and b squared comes in. And I just want to give you an example of what this would look like generically, and then you guys will kind of see how this is going to work in something more specific. So if we've got that point HK as our center, and again, I'm just going to make up an H and a K. Your a squared is always going to be used for, and it really doesn't matter what letter we're talking about here. Some people will overcomplicate this, switch them around depending on whether it's longer or not. That's just nonsense. Whatever is underneath the x is going to control your left and your right distance. So this a value, we can just say is the horizontal distance. From the center. So the horizontal distance from center. So whatever that a is, say it's like a 3, that means I would go 3 in the right direction, I would go 3 in the left direction. So that would be my a value. Just like when I was trying to find the radius for our circles, I do need to take the square root because this isn't just a underneath it, it's a squared. So I need to take the square root to find that a distance. Same thing with what is underneath y, except that b is going to control the vertical distance. So vertical distance from center. So whatever that b value is, we're going b units above the center, b units below the center, and that's going to control that length right there. So really you could see that vertical distance as 2b and the horizontal distance as 2a. But remember, it's not a circle, so your b and your a are not going to be the same. You will end up with either your vertical or your horizontal distance being longer than the other because it is an oval, it's an ellipse. So let's look at graphing number 1, and then we'll talk about what it means by vertices and co-vertices. Really pretty simple once we've graphed it. So with number 1, I'm identifying that center just like in the circle. So I've got a positive 4, positive 2. So my center is at 4, 2. And then remember, whatever is underneath the x value, that's controlling my left and my right. I do have to take the square root, so that means that I'm heading left 3 and right 3. So there's my horizontal distance. Same thing for what's underneath the y value, taking the square root. I'm going to be going up 5 and down 5. Okay, so same as with the circle, I'm just going to sketch this in. I should be able to tell which is longer. In this case, it was a vertical ellipse. So now where the vertices and co-vertices come in, this is kind of interesting, but they're just saying those 4 points are the vertices and co-vertices. The only difference between them is that we call the vertices whatever is furthest from the center. So we notice here that the longest distance is the y value. So my vertices are going to be those two that are the distances up and the distances down. So my vertices would be this point 4, 7, and 4, -3. And then my co-vertices, in this case, will be my left and my right because it was that shorter distance from the center. So I have the point 1, 2, and the point 7, 2. So the vertices and co-vertices change depending on which length is longest. So always the longest length, that's my vertices. And then it's like, oh yeah, the shorter length matters too. They're co-vertices. Okay, let's work another one. So first, my center, looking here, should be at 0, -3. Kind of answer in your head before I say these out loud. In my x direction, I'm going to be going 7 to the left, 7 to the right. Since I'm at 0, that just means I'm going to be 7 away on that x-axis. In the y direction, I'm going to be going 3 up and 3 down. Okay, so there are my 4 points. I can sketch in my ellipse. Now in this case, my vertices, remember it's always the longest, the furthest from the center. So my furthest from the center is my x direction this time. So my vertices are going to be this 7, -3, and -7, -3. My co-vertices are my y direction, so 0, 0, and 0, -6. Okay, we're only going to do one of this type because it's asking the exact same question. It wants to know the center, vertices, and co-vertices of each. The only difference on this is that we're not asked to graph it first. Now, if you needed to graph it to find the vertices and co-vertices, you can. But I want to go at least through the thought process for finding the vertices and co-vertices without graphing. So first, I would go ahead and write down that my center is going to be at 8, 5. And that center is really important to find first because my vertices and co-vertices both are formed from the center. So moving from the center left and right, moving from the center up and down. So first, looking at these two numbers, I can see that my vertices, the longer length from the center here, is going to be my x direction because it was the bigger number. So that means that for my vertices, I'm going to be moving 10 units to the left and 10 units to the right of my center. So since x controls the left and the right, that means that if I subtract 10 from my x value, I would get my vertice on the left. And if I add 10 to my x value, I'm going to get the vertice on the right. And you might notice from the examples that we've already done here that that was already happening. Whatever my center was, so 0, -3, I was just adding 7 and then subtracting 7 from that 0. For the 0, -3, for my y values, I was just adding 3 to it and subtracting 3 from it. Okay, so back to number 4. So there's my vertices. For my co-vertices, I'm doing the same thing but with my y values, and I'm going up 9 and then down 9. So if I went down 9 from that 5, I would have an 8, -4, just subtracting 9. If I went up 9, I would have an 8, 14. So that is how you would find vertices, co-vertices if you weren't going to graph it. For our last two examples, we're just going to be writing the equation of the ellipse given the graph. So we do need to find a few pieces of information looking at the graph, but we're not necessarily going to need the vertices, co-vertices, all of that. So first, I definitely know in my equation that I need the center. So trying to identify the center of your ellipse, and usually you can kind of just eyeball it, but to be certain that it is the center, you would make sure that it is up the same distance as it is down. So it looks like these are both up and down a distance of 7. And then it should be the same distance left and right as well. And it looks like that distance is 4. So just checking in both directions, 7 up and down for left and right. So now that we know that that is the center, that's at the point 1, 0. And then the only other piece that we need for our equation is this 4 and 7. I don't necessarily need to know where those vertices and covertices fall. So now that I have my center, I have that x minus 1 squared plus our y minus 0 squared. So technically you can just put y squared, that's fine too. Our ellipses are always equal to 1, but then we have to worry about that underneath. So our x distance is going 4 left and right, but remember it's a 4 squared, so it would be 16. And then underneath the y is our up and down, and it went up and down 7, but 7 squared is 49. So that would be our equation of the ellipse. Why don't you go ahead and pause the video and try number 6 on your own. Identify the center, that vertical distance up and down, the horizontal distance left and right. See if you can write an equation of this ellipse. So you should have found a center at 1, -1. The horizontal distance was 6 from the center. The vertical distance was 3 from the center. So that would make underneath that x value should be a 36. Underneath the y's should be a 9. Also make sure you have that x minus 1, a y plus 1. You've got both of your squareds there as well, and that they're equal to 1.